This is the Business Blackbook, where billion-dollar empires are built and collapse. What if the next revolution is not happening in a boardroom or a factory floor or a stock exchange? What if it is happening in a laboratory, inside a robot the size of a cooler, on a farm, inside a shipping container, and in the DNA of a single human cell? Technology is not just changing how we live. It is reshaping who holds power, who creates wealth, and who gets left behind. Today, we are going to understand something most people sense, but cannot clearly explain. The world is going through a technology power shift, and it is quietly rewriting the rules of the entire global economy. Let us start with the central question. What exactly is a technology power shift? For most of human history, economic power followed very predictable rules. If you had land, you had food. If you had factories, you had goods. If you had oil, you had energy. And whoever controlled these physical resources controlled the economy. But something is changing at a speed that most governments, most businesses, and most individuals are not fully prepared for. Technology is replacing physical resources as the primary driver of economic value. It is not replacing them slowly. It is doing it sector by sector, industry by industry, in waves that are arriving faster than the previous ones. And the countries, companies, and individuals who understand this shift, who position themselves correctly within it, are the ones who will define the next century of economic power. Those who do not will find themselves on the wrong side of a very wide gap. So let us understand each of these waves, one by one, clearly. The first wave is artificial intelligence entering healthcare. Now, at first glance, you might think this is a medical story. It is not. It is an economic story. Healthcare is one of the largest industries on the planet. It employs tens of millions of people. It drives trillions of dollars of spending every year and for a very long time. It has operated in roughly the same way. A patient comes in, a doctor examines them, a specialist reviews findings. Decisions are made slowly, based on human judgment, accumulated over years of training. That model is being fundamentally disrupted. Researchers at the University Hospital in Zurich discovered something significant. When they fed years of historical cancer biopsy images into an AI system, the system could analyze those images with an accuracy of more than 99%. More importantly, it could identify patterns that trained human pathologists had never considered before. Think about what that means economically. A single pathologist currently takes around 1.5 hours to study the results of a single prostate cancer patient. With AI assistance, that same pathologist could handle 5 patients in the same amount of time. That is not a small efficiency gain. That is a 300% increase in output from the same human resource. Now multiply that across every hospital, every diagnostic lab, every radiology department on the planet. The economic value being unlocked here is not in billions. It is approaching $8 billion in the near term, and that number is considered conservative. But the deeper economic shift is this: AI in healthcare is not just making existing processes faster, it is moving the center of decision making away from exclusively human judgment toward a collaboration between human expertise and machine intelligence. That collaboration changes who is needed, how many of them are needed, and what skills command premium value in the economy. The second wave is pharmaceutical research and the cost of discovery. Drug development has historically been one of the most expensive and risky endeavors in the global economy. Here is a number that should anchor your understanding. Even among drugs that make it all the way to the final phases of clinical trials, 50% of them fail after years of research. After hundreds of millions of dollars of investment, 50% failure. That failure rate drives up the cost of every drug that does succeed, which is one reason medicines are so expensive globally. Now, a company called Benevolent AI is demonstrating what happens when you apply machine intelligence to this problem. Their system scans the entire body of global medical and biomedical literature, millions of research papers, clinical studies, scientific findings, and it identifies patterns and connections that no human team could realistically find on their own. The system suggested that a drug originally developed for a completely different condition might actually be effective against motor neuron disease. Human researchers then tested that hypothesis and found it promising enough to pursue. They raised $100 million in investment to develop this capability further. Now understand the economic logic here. If AI can take the success rate of drugs through clinical approval from around 8% to somewhere closer to 25 or 26%, the entire economics of the pharmaceutical industry changes. Fewer failed experiments, lower development costs, faster time to market, more effective treatments reaching patients sooner. That is not just a healthcare win. That is a massive economic shift in one of the world's most capital-intensive industries. The third wave is perhaps the most visible one for everyday people: the electrification of transportation. Norway has become the most important case study in the world for what happens when a government makes a deliberate and consistent decision to shift its transportation economy from fossil fuels to electricity. The numbers are striking. Between January and June of a recent measured year, 19% of all vehicles sold in Norway were fully electric. When you include plug-in hybrids, that number rises to around 34%. No other country of significant size comes close to that figure. But the more important question for our purposes today is, how did Norway get there? And what does it tell us about economic policy and technology adoption? The answer is not complicated, but it is instructive. Norway removed the sales tax on electric vehicles entirely. It gave electric car owners free parking, exemption from toll roads, access to bus lanes, and charging infrastructure was built out systematically across the country. The result was that buying an electric vehicle became as cheap or even cheaper than buying a petrol car. The incentive to change behavior was not moral, it was financial. This is a critical lesson in how technology shifts actually happen at scale. Technology alone rarely drives mass adoption. The economic incentives around the technology determine the speed of adoption. And Norway had one more advantage that made this particularly powerful. 98% of the country's electricity comes from hydropower. So when critics said that electric vehicles just shift the pollution from exhaust pipes to power plants, Norway could point to an almost entirely renewable grid. The rest of the world is paying attention. Countries are setting deadlines. Car manufacturers are investing hundreds of billions into electric platforms, a global supply chain for batteries, charging infrastructure. Electric components is being built at speed. The economic power in transportation is shifting from oil producing regions to technology developing regions. That is a geopolitical and economic realignment happening in real time. The fourth wave is about where food comes from, and it is more economically significant than most people realize. The United Nations projects that by the year 2050, two-thirds of the world's population will live in urban areas. That creates a structural problem for traditional agriculture. Farmland is rural. Food demand is increasingly urban. Transportation, storage, and spoilage eat into margins at every point. A group of entrepreneurs in Brooklyn, New York, decided to test a different model. They placed a farm inside a shipping container in a car park. Inside that container, crops grow in vertical layers, without soil, in nutrient-rich water, under specially calibrated LED lights. Each container uses approximately 8 gallons of water per day, less than a typical shower, and each container produces over 50 pounds of crops per week. The economics of this model are fundamentally different from traditional farming. You can place it anywhere in a city. You eliminate the transportation cost. You eliminate pesticides. You dramatically reduce water usage. And you can deliver produce to customers within hours of harvesting. Companies like Silicon Valley's Plenty raised over $200 million from investors, including Amazon's founder and Alphabet's executive chairman, to scale this model. This is not a niche experiment. It is a serious economic bet that the future of food production is urban, vertical, and technology-driven. For countries like China and India, which are experiencing rapid urbanization while also watching traditional farmland degrade, this is not an optional future. It may become a necessary one. The fifth wave is genomics, and it may be the most economically transformative of all of them, because it has the potential to change the economics of human health at the most fundamental level. A gene editing technology known as CRISPR-Cas9 has been described as potentially the greatest scientific discovery of the 21st century. To understand why, you need to understand the current economics of disease. Right now, most medicine is reactive. You get sick. You receive treatment. The treatment manages symptoms or attempts to cure. But the underlying genetic cause of many diseases, the actual error in the code of your cells, remains. CRISPR-Cas9 changes that model. It allows scientists to locate a specific sequence in the human genome, cut it with extraordinary precision, and replace it or repair it. Almost any condition where a gene is the root cause becomes, in principle, something that can be fixed at the source. The economic implications are profound. Diseases that currently require lifetime medication, expensive procedures, or ongoing management could potentially be cured with a single intervention. That fundamentally changes the cost equation in healthcare, and the cost of the technology itself is falling rapidly. Sequencing an entire human genome used to cost approximately $2.7 billion. That cost has already dropped to around $1,000, and it is projected to fall to a few $100s within the next few years. When sequencing a genome costs less than many routine medical tests, the entire model of how medicine is practiced and how healthcare economies are structured begins to shift. But here is where the story becomes more complicated. There is a serious problem at the foundation of the genomic economy, and it is a problem of data diversity. Right now, 81% of the world's genomic information has been gathered from people with European ancestry. India makes up 20% of the global population, but the DNA sequences of its people represent only a tiny fraction of the world's genetic databases. 60% of the world's population accounts for less than 5% of global genomic data. Why does this matter economically? Because the drugs being developed, the treatments being designed, the precision medicine being built is largely being calibrated on one group of human beings and then being sold at premium prices to the entire world. That is not just a scientific gap, it is an economic and ethical one. The populations with the least representation in the data are often the populations with the greatest healthcare burden and the least ability to afford treatments that may not even be optimized for their biology. Correcting this imbalance is not just a matter of fairness, it is a massive economic opportunity. Companies that build diverse genomic databases will have a significant competitive advantage in developing drugs that work better for more people. The sixth wave is cybersecurity, and it is the shadow economy that most people underestimate. As every industry in the world becomes more connected, as every device becomes a data point, as every company builds its operations on digital infrastructure, the attack surface for hackers grows with it. Security firm Trend Micro reported blocking more than 2,500 hacking attempts every single second. Not per hour, not per day. Every second. In a single year, they detected more than 74 billion attempted breaches by email and more than 5 billion by malicious files. A particular threat that has emerged for businesses is something called whaling. Unlike ordinary phishing, which sends generic fraudulent emails to large numbers of people, whaling targets the most senior executives in a company, the chief executive, the finance director, the people with access to the most critical financial systems. The FBI found that more than 17,000 companies around the world were hit by business email compromise between 2013 and 2016. The total cost, more than $2 billion. Now, here is the economic point. Every company that digitizes, every factory that connects to the internet, every hospital that moves patient records to the cloud, every electric grid that becomes smart, adds to the target landscape. Cybersecurity is not just a technology cost. It is now a fundamental operating cost of the modern economy. And the companies that build the best defenses, the people with the most sophisticated skills in this domain, are commanding extraordinary economic value. The seventh wave is brain-computer interfaces. And while it is the most futuristic of the themes we are covering, it is already showing early economic signals. Facebook announced a team of 60 engineers working on software that would allow people to type using only their thoughts. Elon Musk's company Neuralink began exploring how direct brain interfaces might treat chronic medical conditions and eventually allow humans to upload and download information. At Imperial College London, researchers have already built a working system, a robotic glove controlled by eye movements, allowing people with paralysis to grip and release objects. A simple wink of the eye closes the hand around a bottle of water. Almost 10% of the population in most countries has some form of movement disorder or paralysis. The economic value of technology that restores function to those individuals, reducing dependence on caregivers, enabling participation in the workforce, is enormous. And the broader commercial applications extend beyond medicine. Rescue workers, military personnel, deep-sea operations, any environment where hands-free control of machinery would increase safety and efficiency. The economic potential here is early stage, but the investment by the largest technology companies in the world signals that those who understand the direction of power are already placing their bets. Now let us address some things that are commonly misunderstood about this technology power shift. The first misconception is that technology adoption happens automatically once the technology is ready. Norway disproves this clearly. Electric vehicle technology existed for decades before widespread adoption happened. What changed was not the technology. What changed was the policy framework around it. Remove the tax, subsidize the infrastructure, change the incentive structure. Then adoption accelerates. Technology without economic incentive alignment moves slowly. Technology with economic incentive alignment moves very fast. The second misconception is that AI will simply replace human workers across the board. The more accurate picture is nuanced. AI is replacing specific tasks, not entire professions. A pathologist using AI can process 5 times as many cases. That pathologist is not replaced. They are augmented. Their output is multiplied. Their time can be spent on the most complex cases that genuinely require human judgment. The economic disruption comes not from elimination, but from restructuring. Fewer people needed for routine tasks, higher demand for people who can work alongside the technology, train it, interpret its outputs, and make judgment calls it cannot make. The third misconception is that data is neutral. The genomics example destroys this idea. When 81% of your data comes from one demographic group, every algorithm you train on that data carries a built-in bias. The technology works better for some people than others. And in medicine, that is not a minor inconvenience. It is a matter of life and quality of life. Data is economic power. Whoever controls the data controls the quality of the output, and the communities that are underrepresented in data are systematically disadvantaged in a technology-driven economy. The fourth misconception is that privacy concerns will slow the technology down in any meaningful way. The honest answer is that privacy is being traded voluntarily by billions of people in exchange for convenience, speed, and personalized services. Consumer DNA testing companies have built databases of millions of genetic profiles precisely because people chose to share their most intimate biological information in exchange for insights about their ancestry and health. The economic model works because the value exchange is perceived as worthwhile by the individual. The challenge is ensuring that the regulations governing that exchange protect people from being exploited without their understanding. So, what does all of this mean in terms of real-world economic impact? For students entering the workforce today, the skills that command economic value are shifting rapidly. The ability to work alongside AI systems, to understand data, to build, maintain, and interrogate intelligent tools is becoming foundational in the same way that literacy was in the industrial era. The student who understands how genomic data creates drug development advantage, who understands how renewable energy economics change geopolitical power, who understands how cybersecurity is a cost of doing business in the modern economy. That student has a significant advantage over one who does not. For salaried professionals, the question is not whether technology will affect your industry. It will. The question is whether you are building an understanding of how it affects your specific domain and whether you are positioning yourself as someone who enhances the technology or someone who is at risk of being replaced by it. For business owners, the economic shift creates both threat and opportunity simultaneously. Every industry now has a technology-native competitor either already in the market or approaching fast. The question is whether you are investing in understanding that competitive threat and whether you have the capacity to adopt the technology before the disruption becomes existential. For middle-aged families thinking about where economic security comes from, the shift is uncomfortable but important to understand. The stability that came from being in an established industry with predictable career paths is less reliable than it was. The industries themselves are being restructured beneath the people working in them. Understanding where value is flowing and positioning family financial decisions around those flows rather than the assumptions of the previous generation is one of the most important applications of this knowledge. What should a financially aware and strategically thinking person take from all of this? The technology power shift is not a single event. It is a series of overlapping waves, each one building on the infrastructure and understanding created by the previous one. AI creates the tools. Genomics creates the data about human biology. Cybersecurity protects the infrastructure that both depend on. Electric vehicles and renewable energy create the clean infrastructure the whole system needs to run sustainably. Urban farming applies the same data and technology logic to food systems. Brain-computer interfaces will eventually close the loop between human intent and machine execution. These are not separate trends, they are parts of the same underlying transformation. Economic power is moving toward whoever controls the data, builds the most capable AI, secures the infrastructure, and aligns policy incentives with adoption at scale. The countries that understand this, the companies that position themselves within it, and the individuals who invest in genuinely understanding it rather than being passively swept along by it, are the ones who will define what the next version of economic power looks like. This is not about fear. It is about clarity. The shift is happening regardless of whether any individual understands it or not. The only question worth asking is whether you are going to understand it or not. And with that, the Black Book closes. Subscribe, and we will open the next page soon.